We built a haunted photo booth for our Halloween ghost town, and in this video I'll show you how it works and how we made it.
Let's mount up.
Howdy. Come on in and take a seat. I've been waiting for new victims. Customers. When you're all set, just press that flashing button right in front of you. Now, we're gonna take 3 pictures to make sure we get a good one. Looking good. Let's take another. That one's a keeper. One more now. Oh, I hope I didn't frighten you too badly. Take a gander at that screen below to see your pictures. Well, thanks for stopping by. Hope you like your photos. Y'all come back now. Now, we're going to take 3 pictures to make sure we get a good one. Looking good. Let's take another. That one's a keeper. One more now. Oh, I hope I didn't frighten you too badly. Take a gander at that screen below to see your pictures. Well, thanks for stopping by. Hope you like your photos. Y'all come back now.
So as you can see in the demonstration, the photo booth is kicked off when it detects motion. The motion sensor was mounted up on the wall so that when somebody walked inside it would go ahead and detect that and get started. And a quick note, before we get too into this, the voiceover that you hear, that's all custom voiceover work. We went on Fiverr and looked for people who did that and found somebody who does a great cowboy voice and basically wrote a script, sent it over, and he recorded it. We were super happy with how that came out. I think it really adds a lot and a lot of character to the photo booth. So yeah, once that motion is detected, go ahead, it plays the welcome message and shows a message on the screen, and then it basically starts flashing the start button. So then it just sits there and waits for the button to be pressed. And then after a certain amount of time, it'll go ahead and restart. If it detects motion, it plays the whole spiel again and starts flashing the button. And if no motion is detected, it'll just kind of go into standby mode and wait until it detects that somebody's in there. So after it starts, it basically takes 2 normal photos, and then on the 3rd photo it shows that countdown like it's getting ready, and then it pops up and it kills all the lights, pops up an error screen. And that was pretty funny because some people actually started walking out of the photo booth thinking, oh, there's something wrong, and telling us, hey, something went wrong, guys. We were trying to include enough of a pause in there to kind of get people to wonder what's going on. Of course, I'm sure a lot of people knew what was coming, but it was fun, and I think it was effective in getting that scare going. So then, of course, after it sat there for a little bit, it triggered the lights on the skeleton, it triggered the motion, the vibration motor under the seat, and it was supposed to trigger the air cannon as well. We did have some technical issues with that that need to be resolved. So before it takes the pictures, it generates a unique code, and it uses that code in the file name of the photos. And then once the photo booth is done, it prints out a receipt on the thermal printer. It has that code on it, as well as a website where they can go and download the pictures. It was just like a basic website that I made with some simple functionality to go ahead and look for those files and display them so that people could view and download them. This is the camera for the photo booth. It's modeled on an antique View camera. What I did is just look for lots and lots of reference images online, and I looked up ones that you could buy on eBay and places like that to get some ideas. The lens here is 3D printed. I designed that in Fusion 360 and printed it out. It was printed in 3 different parts. The base here, this ring on the end, and then the lens area. I designed it so that the Raspberry Pi camera module would connect on the inside there and blend in with the style of the lens. The body of the camera is just made out of pine. I found some different pine boards at Lowe's and cut them, assembled them together with a pin nailer and some glue, and then I stained it. The bellows for the camera was made using this Bristol paper and cloth adhesive tape. This is basically also called hockey tape. People use it for taping up hockey sticks and things. And I found a tutorial online that showed you how to accomplish this. It's basically just making some measurements and then lots and lots of folds. I used brass hardware on the camera, and then I used an aging solution to weather the brass so it wasn't shiny and new. Take a look at the inside of the camera. You can see I've got a bolt here. This was used to bolt the camera to the crate below. There's a hole right there that the bolt goes through. And then this is the camera cable for the Raspberry Pi camera module. This end here plugs into the Raspberry Pi. And if you look all the way down there, you can see the Raspberry Pi camera module. And that is just attached with hot glue on the end there. Alright, so let's take a look at the brains of our photo booth. The photo booth is run by this Raspberry Pi computer right here. This is a Raspberry Pi 3 Model B. It's had plenty of power to run the show. The software for the photo booth is written in Python. What I did is look online for examples and found quite a few different examples of Raspberry Pi powered photo booths, and I kind of used those as a jumping off point in writing my own software. So that worked out really well. Over here, this is a future expansion board. This is a Scary Terry audio driver board. This is used for a talking skull. I wanted to get that done this year, but just didn't have time. I did have the board mounted in case I figured it out, but basically you connect your audio through here and a servo. Servo runs to a skeleton that moves the jaw, and it'll talk in sync with the audio. So I left that on there for future expansion because it would be great to have the skeleton in the photo booth talk and move along with the audio. On the other side of the mount here, this is an 8-channel relay module. This is hooked up to the Raspberry Pi over here. And then this is an RCA jack that I had lying around. And this is what is connected to the relay board. So when it comes down to it, it's actually fairly simple to accomplish the different effects that we wanted to in the show. It's really just about turning things on and off at the right time. So that's where this relay board comes into play. Now you can see right here all these wires up here. These are all connected to the Raspberry Pi. Now the Raspberry Pi has what's called GPIO, basically inputs and outputs that you can control programmatically. And down here, these are the power wires. Basically, what happens is the Raspberry Pi controls whether these relays are on or not. So these are basically switches, and the Raspberry Pi is controlling whether they are on or off. So you supply power separately to this module. So basically it's just links between each relay, and then the outputs of the relay, the output of the switch, is going over to this RCA jack. And I decided to do this since it works out really well because you can just use RCA wires. I've got a lot of those lying around. We use them for all of our lighting and our HUD, so it worked out great. Now, for example, here's one of these spotlights. This was used during the scare, and you can see it has an RCA jack on the end there, so basically I would just need to run a wire from this to the correct output. Now I have these saved in my code. I have a listing of what each one of these needs to connect to in order for it to control all the proper items. So with these relays I was controlling different things like lights. So we had two lanterns in the ceiling that kind of served as the house lights. There was also a spotlight that was aimed at the skeleton, and that was also considered a house light, so it was controlling that. Like I said, it's controlling spotlights that were used during the scare. It was also controlling the motor. There's a vibration motor that's installed in the crate that you sit on. Again, it's just a matter of applying power to the motor, it turns on. There was also a connection between one of these relays and the solenoid on the air cannon. This is an air cannon that is used as part of the scare. You can see here this has the same RCA electrical connection, and that triggers the solenoid right here. And then there's a regulator on here to adjust the output pressure. One of those relays also controlled this flash when it was taking the picture, and this is modeled after an antique flash powder flash. Obviously I wasn't using gunpowder to create the flash. This is just an LED light strip. To make setup a little bit easier, I used wire connectors for various components of the system. So you can see here this is the start button. There is two wire connections on this. One here is for the switch aspect of this arcade button, and then this is for the internal LED, and this actually just hooks up to one of the relay modules. Over here we have the PIR. This is a motion sensor, and this is what was used to start the show. It worked out really great. I mounted it on the back side of the room, so when people came inside the curtain, so it started off the show like it should. Here we have the thermal printer, and the idea with this is it would print out a unique code and website address so that they could go ahead and download their photos at home. The software worked great. Unfortunately, this thermal printer gets jammed very easily. And we all know that kids are not the most gentle beings on this planet, so when they would go to rip off their receipt, one of two things happened. This door popped open very easily and the roll of thermal paper would pop out. We tried to fix that by putting some electrical tape on here. Still wasn't enough. Even if this did remain closed, the other problem is it would kind of get bunched up on the end and then it would stop printing. So in the future, I still think it's a cool idea to be able to output a receipt like that. So in the future I might look for a different printer, or maybe see if there's one with an automatic cutter. On the Raspberry Pi right here is where the camera plugs into. This is an HDMI port that's plugged into the monitor that I used for the display. And then down here you can see this is a little wireless receiver for this keyboard. This is a wireless keyboard and trackpad, and that made it very easy to modify the software and control it when it was all set up outside. This is the audio out of the Raspberry Pi, and I just had that hooked up to a set of powered speakers that were set up next to the crate. In the future I would like to add integrated speakers into the crate. That way it would just look a little cleaner to not have the extra speakers on the sides. I found this hat here for the Raspberry Pi. Basically any kind of expansion board that connects to it is called a hat. And this worked out great because this connects onto the GPIO pins of the Raspberry Pi, and it gave me all these screw terminals here. So that way I could make good solid connections with all the different wires that I needed to. To mount this project I used DIN rail. This is something that was originally developed back in the 1920s by the Germans, and it's been used ever since in some form or another to hold terminal blocks and different electrical and computer components inside racks and things like that. So people seem to be using it a lot more for DIY and maker stuff, and that's how I found out about it. So I got the DIN rail there, and then I made these, I designed and printed these legs here to hold the rails, and I set it up so that I could put rails on each side and additional rails down here if I wanted. And then I went ahead and printed out the clips for the different components, and I just made custom clips for each different component, and it worked out great. The nice thing about this is these components can easily move around or unclip from the rail, and it makes it easy to work on things and switch things around if you need to. It also leaves room for expansion in the future. Well, that's going to do it for this video, guys. I hope you enjoyed it. I definitely had a great time working on this photo booth project. It was a lot of work, a little challenging, but I'm very happy with the end result. I think everybody on Halloween had an awesome time and really enjoyed checking it out. So I'm really happy about that. If you like this video, go ahead and give it a thumbs up. And if you're not a subscriber and would like to see more videos like this, go ahead and hit that subscribe button and you'll be notified of future videos. Thanks for watching, and we'll see you next time.